Alright guys, today's goal, the learner will understand how to solve equations involving exponential and logarithmic functions. Exponential equations are in which the variable expressions occur as exponents. See how here they get the bases to match? We were talking about this yesterday. That's what we need to do more of. Okay? So 9 to no power equals 27, but 3 squared is 9, so I can change that one to 3 squared equals, and 3 to the third and then remember, when you have a power to a power, you multiply. So 2 times 2x, that'd be 3 to the 4x, equals 3, and then distribute. So 3 times x is 3x, 3 times negative 1, negative 3. Get rid of the bases now, so you get 4x equals 3x minus 3, subtract 3x, x equals negative 3. Okay, so anytime you see a whole number in a fraction, one of the exponents needs to be changed to a negative. So I know here 3 to the fourth is 81. So I'm going to change that to 3 to the fourth. And then you have 3 minus x. But 1/3 is the same thing as 3 to the negative 1. 5x minus 6. So just power to a power, we multiply. So you got to distribute. So I get 12 minus 4x equals 3 to that, equals 3 to the negative 5x plus 6. So we can get rid of the bases. Add the 5x over. So you get 12 plus x equals 6. Subtract the 12. X equals negative 6. So there we go. We have to get the bases the same. So there's exponential. So now what do we do? Well, there's 5 and 2 will never be the same base. So what's the inverse? Log. Okay? So watch what I do here. I need to worry about the one that has the exponent in it, or the variable in the exponent. So I go log base 2 of 2 to the x equals log base 2 of 5. See how I took the log of the same base on both sides? Now, didn't we learn we can take this x and bring it down to the front? Okay, so I have x times log base 2 of 2 equals log base 2 of 5. Well, log base 2 of 2 is 1, so I get x equals log base 2 of 5. And then remember, now we can say x equals log of 5 divided by the log of 2. Okay? So here, log base 7 of 7 to the 9x equals log base 7 of 15. You match the base of what the exponent variable is, okay? Bring that 9x to the front. 9x log base 7 of 7 equals log base 7 of 15. So I get 9x equals log base 7 of 15. Well, I know that's equal to log of 15 divided by the log of 7. And since we have a fraction over there, instead of dividing by 9, you can multiply by 1/9. So I get x equals log of 15 divided by 9 times the log of 7. And we can enter that into our calculator. We just got to make sure we use parentheses. So here we got to do a couple things first. Got to add that 7 over. So add the 7. Divide by 4. Take the natural log of both sides, and I'm also going to bring down the exponent. So why am I doing natural log? Because that's e. Natural log of e is 1, so you get negative 0.3x equals the natural log of 5. If you don't remember how to put these into your calculator, ask me tomorrow, okay? So here's the thing, guys. It's the same thing. Solving logarithmic equations. Logarithmic equations involve logarithms of variables. See how they have log base 2 of x, log base 2 of 7? So x equals 7. It's the same thing. So see how here we have natural log, natural log. When that happens, you just get rid of them. So get rid of the natural logs, because what you can do is say e to that power, and it cancels it out. So you get 7x minus 4 equals 2x plus 11. So subtract this 2 over, add this 4 over. 5x equals 15. So x equals 3 because you divide by 5. So you get x equals 3. So those are the easy ones. So are these here. Now, this, they don't have log base 2 on the same side, so you can't just do that. But what is the base of this? You go 2. So you go 2 to that power, 2 to that power. So you get x minus 6 equals 2 to the 5th power. Because those cancel each other out. 2 to the 5th power is 32. So you get x equals 38. Another way to think about this is just changing it to ben. Because you'd get 2 to the 5th equals x minus 6, which is the same thing we had, okay? So let's try a couple more. Alright, so the big difference here is we have 2 of them. But what did we learn we can condense with? Remember, this means multiplication, so this means log of 5x times x minus 1 equals 2. And then that'd be log of 5x squared minus 5x equals 2. So then you go, you can either, so then you can go 10 to that power, because that's the base, 10 to that power. Because remember, if log doesn't have a base written, the base is 10. So you would, those cancel out, so I have 5x squared minus 5x equals 100. Subtract the 100 over. Divide everything by 5. So I get x squared minus x minus 20 equals 0. So I have to factor. What multiplies negative 20 and adds a negative 1? Negative 5. Positive 4. So I get x minus 5 equals 0. X plus 4 equals 0. X equals 5. X equals negative 4. But see how it says check extraneous? The 5 will work. But if you try to put extraneous means plug it back into the original. So if I have log of 5 times negative 4, go ahead and hit log of negative 20 in your calculator. And it's going to come up an error. So that is extraneous. Okay? So last one. Addition, we can condense. Addition means we can condense these together using multiplication. So you get log base 4 of x squared plus 12x equals 3. And then you could just do this, change it to the ben. So that would be 4 to the third equals x squared plus 12x. Well, 4 to the third is 64. Subtract that over. So you got to figure out what multiplies to 64 and adds to 12. And I am striking out right now. Let me think about this for a second. I was thinking positive 64, but it's negative 64. So you get x plus 16, x minus 4. So I would get x plus 16 equals 0, x minus 4 equals 0, x equals 4. That one checks. X equals negative 16. Plug it back in. It would give you a negative right here, so that one does not check. So I get x equals 4. Alright guys, see you tomorrow.